Now we've seen all the concepts in the functional paradigm that we will use in the course. So we can now define the full kernel language. First, I've said how functions and procedures are the same in the kernel language. Let me first give an example to explain that. I'll start with a function definition and I'll convert it to kernel language in 2 steps. So here's a function definition. Inc x, x plus 1, end. This function inc, let's first turn it into a procedure. We do that by adding an extra argument, which represents the output. Procedure inc y, y is equal to x plus 1, end. And the final step is converting it to a value, so that we see clearly that the procedure is a value. So we have inc is equal to proc $xy, y is equal to x plus 1. So this final one is actually the kernel language. So we have here a kernel language definition of the function inc. So before today's lesson, we saw that the procedure declaration as an instruction, and we saw lists as a primitive type. Well, in today's lesson, we saw 2 new ideas: procedures as values and records as the true primitive type. So in the full kernel language, we have to show that. So let me bring in a diagram to show how we can go from what we saw before today to the full kernel language. So this is what we have seen so far before today's lesson. So notice here, procedures are declarations, and here we have a lists and patterns as the primitive data types. So remember, the lists are recursive, but since they can be built incrementally, we need to also to be able to represent a list as an identifier. So this is what we've seen so far. Okay? In order to become the full kernel language, it needs 2 changes. First of all, the procedure declarations should be values. They should no longer be declarations. They should be creations of procedure values. And the second one is the lists. So lists should go away and be replaced by records as the primitive type. So we need these 2 changes in order to get the full kernel language. So let's do the first change. So we remove the procedure instruction as a declaration, and we add here a procedure as a new kind of value, in red here, procedure, which is the procedure values that we use in the examples with the $ as the placeholder for the identifier that's not in the value. So notice that the values are now numbers, procedures, lists, and other things. So this is the first step. Procedures are now values. The second step is we remove lists here, we remove them, and we replace them by records. So a record has the following syntax. It's either a literal is an atom for now, and here the literal can be the label of a record. It's also an atom, and here F1 to Fn are the feature names, which can be either atoms or integers. So both patterns and record values have this syntax. So notice that lists can be then encoded as a form of record. And this gives us now the complete kernel language. So let me show it in a nice way. So this right now, this particular diagram is the complete kernel language of the functional paradigm we will see in this course. This allows to illustrate many programming concepts. It allows, because of procedure values and because of records, to define many more sophisticated concepts such as object-oriented programming, but also things like component-oriented programming, software components, modules, and many other kinds of abstract concepts. So with this, we are now set for the rest of the course in terms of the kernel language.